Alright, so you've got a dead IGBT module. Chances are you've attempted a repair, like I have in the previous video, and you put it in a bike and it doesn't work. So the next thing you want to test is whether the IGBT is actually okay. One of the ways you do this is you measure the diode voltage between every terminal and the resistance, and then compare it to the data sheet. So it's actually a European part, so although on the board it's labelled phase A, phase B, phase C, it's actually W, V and U. So what you're going to need to do is make up a bit of a table. That's a V, this one's a U, and then positive, negative, negative. And what you need to measure is the diode voltages between each one. So you just grab a multimeter. It doesn't have to be as fancy as this, most of them do it. You're setting it to resistance or diode voltage. This particular one, it'll have a diode symbol. So the diode symbol, it doesn't show up so well on the camera. Diode symbol is this. That's the diode symbol. And so what it does is it sets the multimeter to put voltage through the two probes, and then until it conducts basically. So from battery negative to there, 0.324 volts. So that's between the negative and W, 0.32 volts. And it should be the same for all. If you get them the wrong way around, it'll just read infinite. So don't worry. It'll read something momentarily, but that's mainly because the capacitors will take some of the voltage. Yep, so 0.32. If it goes a little bit crazy, it means you haven't really got a good connection. I could probably fix this by putting a stud in, but yeah, 0.32. Same deal for the positive side. You want to be measuring positive to each phase, and again you're expecting to see 0.32 each time.
Okay, I can't see which one you're actually touching.
Ah.
Let me just come around. Let me come around so I can see better.
Yeah.
Okay.
How's that? Alright, so again, we'll go. Whoop. I know it's back to front, but you have the negative lead on the positive terminal, the positive lead on the negative, or on the phase rather. So 0.32, 0.32, 0.32. I'm less concerned about what the third number says, because this particular multimeter isn't that accurate, and I dare say it, most aren't either. There's my pen. 0.32, 0.32, 0.32. I'm not so concerned about what the diode voltage is between the two, between the positive and negative terminals, because it should be infinite. Oh no, it's half a volt. That's interesting. 0.49. So positive is 0.49. Actually, which way around was that? Is that way? Yeah, opposites, positive to negative. The next one is to measure the voltage between terminals. should be infinite for all directions. If it's not infinite, then you got issues. Which is fine. Alrighty, so that's passed that test. The next one you want to check is resistance. And it should be infinite between all of them. So that's infinite, that's infinite, that's infinite. It won't really be infinite, it'd be in the high mega ohms, but it's more than the multimeter can measure. So if it passes all that, basically the output of the IGBT is going to be okay. So your next trick is to measure what the inputs are doing. That'll be the end of the test. Alright, so now we're going to remove the IGBT module from the actual motor controller board. The first thing you do is you cut all these pins short. There's 13 of them or so, and you're trying to cut them as close to the board as possible. Even if it's a known good IGBT that you're going to swap into another board, you still want to cut them short as possible. Having long pins doesn't help you any. It's usually helpful to get the pins out of the way. At this point you should also be warming up your desoldering station. I use a vacuum version, but you can use a braid as well. It's just I find the vacuum to be much easier. Okay, so once that's up to temperature, and that made no difference. Well, basically what we're trying to do is desolder each pin so they end up being loose. So you can see that pin there now moves pretty freely. That's exactly what you want. If the board's never been desoldered before, you'll actually have a layer of conformal coating. It's actually over the entire board, but it will cover your all the pins as well. So it may make a bit of a mess when you're getting through it. In the comment section, I'll put a link to exactly the exact vacuum soldering station that I'm actually using. It's only a cheap one. It's not that fancy. It's not that fancy, but it does the job pretty well. couple are a bit of a pain, just because of how close they are to the location pins. So you might have to grab it from a different angle. And once you reckon you've done them all, you should check them with just a screwdriver, a little one, to make sure that all the pins are actually free. Any that aren't, you need to redo. So they should just move pretty freely. Alright, so pins 1, 3, 4, that fourth last one. One, 3 and 4 need to be redone, so number 1. Okay. Once you've done that, your next job is to take off all these bolts. 10mm socket we normally do, as long as you can get down on it far enough. Doesn't matter if you lose them too much, because we'll be replacing them with copper ones, because the originals are actually made of steel and they're nickel plated, which is pretty craptacular. How I got this one in. Oh, there we go. Struggle with it. It's going to involve a pair of pliers soon. There we go. Right, next fun part is the board. The IGBT module is glued to the board with silicone. Great stuff for making it stick forever, but a pain when you want to get it off. There's my knife. I normally just use an old kitchen knife or something. You want to have a slight bend in the knife, so you're bending it away from the board. And you're basically just cutting through this silicone. You've got to go all the way around.
Be careful of the studs.
Yes, you will run into the studs eventually. The studs normally will survive a kitchen knife. Kitchen knives cut okay through silicone, but not so much through steel. At least in my experience. Depends how hard you push, I suppose. The studs on the actual IGBT aren't bonded to the motor controller board at all. So you can get a knife down between the board and the studs. Oh. In fact, it's more a case of you pretty much will need to get to some of the plastic. Same deal on the other side.
The pins.
Yes, the pins are also a problem. Fortunately, I haven't cut through them yet, but it's a first for everything, I suppose. It does take a little bit of brute force and ignorance to get in there. Okay, and the next fun part is prying it off. Now, what you're doing at this stage is lifting up to see what silicon's still in the way, if any. So you can see there that it's still bonded all the way at the back. Not sure how well that came up on the camera, but it just means I've got to run the knife down there a bit more. You lift it up all the way around, preferably where you can get the tip of the screwdriver against the IGBT module and the insulated part against the board, because you don't really want to damage the board getting the IGBT module out. Still pretty well stuck down there. The conformal coating adds a bit of trickiness to getting a knife in there. Oh yep, there we go. Now it's pretty much free. And it's off. Now this one, it's actually come off very cleanly. There's actually no bits still attached to the pins. I'll show you one I did earlier that didn't come out so well. This one, no, it wasn't that one. Oh, Actually, I don't have them. Anyway, if they don't come out so well, what happens is some of the tracks on the actual board come out stuck to the pin, which is really undesirable because it makes it very hard to solder the next board in. The next thing we want to do after we've got the board out is drill out or Dremel out these 3 pins. I pointed that one earlier, but we don't want to do that. It's definitely these 3 pins that we want to do, because they're not electrically connected to anything inside the board. They're just sort of spaces. Drilling them out will allow us to use these much thicker, heavier copper terminals rather than the nickel-plated steel ones, which should reduce the likelihood of burning out at the terminals in the future. Yep, that's enough for the filming.